we're going to be looking at trigonometric identities. Now, let's look at this triangle here. This is our triangle, and we have a right angle triangle right here. Now, let's say we have the sides A. So you have the horizontal side A, vertical side B, and the hypotenuse of this right angle triangle is C. And let's say we have the angle here. Let's call it theta. Alright? You know that theta is a Greek letter, and sometimes it's used to represent angles. Now, you remember the sine ratio. The sine of theta is the opposite side. Remember, theta is on the left and B is on the right. So they are on opposite sides of the right angle triangle. So it's opposite, which is B, divided by the hypotenuse. The hypotenuse is C. Okay. You also remember that the cosine of theta, don't need the brackets, the cosine of theta is the adjacent side, right? Remember that both C and A are adjacent to theta, but A is the one considered the adjacent, since you consider C already as the hypotenuse, right? Just revising what you would have known already. So the cosine of theta is adjacent, which is A, divided by the hypotenuse C. Alright. Now, let's see something here. So, no, there is what you call trigonometric identity, which you would see in a lot of places, that says the sine squared of theta plus the cosine squared of theta is identical to 1. Now remember the identity, right? You represent it with 3 strokes, because any number you put in for theta, it will work. It's not like an equation where only certain numbers, maybe 1, 2, one number for a linear equation can work and all numbers cannot, other numbers cannot. Or 2 equations will work for a quadratic, but any other numbers can't work. So only 2 answers you have. Or for a cubic equation, only 3 answers, and any other number you substitute will not work, right? With the identity, any number you put in will work. Let's test and see if this identity is really true. We don't want to just accept it like that. Let's see if it would really work out, alright? Sine squared theta is the same as sine theta squared, alright? Plus cosine squared theta, as I have it up here, is the same as cosine theta squared. Alright? Now what would that be? That would be the same as b squared, b over c squared. Because remember, we said sine theta r squared. Same thing as sine squared theta, right? This is just another way to write it. Sine theta r squared is b over c r squared, because sine theta is b over c. So sine b over c is that. So let me write it below to line it up with the sine squared. This is b over c squared plus b divided by c, all squared, plus this is a divided by c, all squared. Alright? Now, that now is equal to what? This would be b squared over c squared. Remember, you can separate the numbers that are divided and square each of them individually. Alright? Alright. So, it's b squared over c squared plus a squared over c squared. See that? This can be written as b squared plus a squared divided by c squared. You remember your fractions, right? Okay. Let me just put this thing in alphabetical order and put a squared first plus b squared all over c squared. What does that give you? A squared plus b squared is what? Let's look back at the triangle here. Here. If you use Pythagoras to solve this, Pythagoras theorem, Pythagoras theorem says the hypotenuse squared is one of the other sides squared plus the next side squared. Alright? Remember, it says that the square on the hypotenuse is the sum of the square of the other two sides. So, square on the hypotenuse is this side square plus this side square. So, c squared is equal to a squared plus b squared. Let's write it down below. C squared equal a squared plus b squared. Same thing as saying a squared plus b squared equals c squared. You see that? Alright. Now, if a squared plus b squared is equal to c squared, it means that this is equal to this, which is equal to this. Right? So I can just say, when I write a squared plus b squared over c squared, since a squared plus b squared equals c squared, let's write c squared up top. C squared over c squared. That would give you what? 1. So therefore, what I have here is that this is 1. So this is equal to 1. But this here is the same as sin theta squared plus cos theta squared. So I can write this as 1. But this thing is the same as sin squared theta plus cos squared theta equals 1. Now, as I said, any angle you put in for theta will work. We'll say sin squared theta plus cos squared theta equals 1. So now, in order to show that this is not just an equation where only certain numbers you put in for theta will work. Any number you put in for theta will work. You put the third stroke. So you call that an identity. So this is our first identity shown. Alright?